That. So our next speaker, that's Steve #3, as I begin to refer to him, is actually someone that I first met almost 20 years ago. He published a book that very possibly could have screwed up my life if I'd taken it too seriously, about riding a bicycle across America and playing with neat, cool toys. So, so thank you for not quite doing it. Yes. We won't go there. So Steve is now a hermit on Camino Island. Yes, trying to move to a sailboat. So he's here to talk about his latest adventures and some of the things that he's done with amateur radio. So Steve. Yes.
Okay, I'll be louder. All right. Well, I like the way Dan started his talk by mentioning a formative event in his childhood about getting excited about radio. I like the switch. Mine was, I was kind of becoming a geek, but I lived in a place where that really didn't have much cultural relevance to the surrounding area. I grew up in Kentucky, and the neighbors were into fighting and whatever. And I went to a different school, and I was kind of the weird kid in the big house who was into electronics, and everybody else was doing things that rednecks in training do. And one day I was on my way home from school, and I had my science fair papers all with me, and of course this was before word processors, obviously. I was 12, so it would have been about 1964. And it was the summer of the squirt guns, and guys saw me coming, get Roberts, and they came after me on their bicycles and hosed me down with squirt guns. Well, I mean, normally that would just be mildly humiliating, but it ruined my science fair report, which I'd been working with for days. And these were all guys who could have just destroyed me if I attempted to fight with them. But I went home and I was just shaking, I was so angry. And I decided that there was a technological solution to the problem. So Forrest Mims had just published this tickle stick in Popular Electronics magazine. Old-timers may remember it. And kind of like a paleo stun gun, about 15,000 volts. And so I took two squirt guns and I mounted them on a wooden stock with a single handle and a lever so that I could squirt two streams of water that were parallel. I put salt water in the squirt guns. I built this tickle stick and mounted it in a little box. Of course, you see where this is going. A few attempts to solder the little brass nozzles, and finally made some little clips because it kept melting the plastic. And finally, as long as I had the two streams of water that didn't break up into droplets, it would work. And so I went trolling Linwood Way with this thing hanging on my bicycle, and sure enough, get Roberts, and I started playing about me with this thing, and the kids were falling off their bike and twitching and denting. Amazingly empowering adventure. And then I ran out of water. I was like, oh, I didn't think about that. And so I hightailed it home and hid in the basement after reloading. So it was destroyed. They never followed up on that. I guess it's an early example of the sufficiently advanced technology being indistinguishable from that. So anyway, I decided somewhere along the way there that really what I want to do is play for a living. And the tool for doing that is, of course, gizmology and other things that we like to play with, because you can layer that on top of just about it. So I just threw this in here because it was before my nomadics. In 1974, I built what turned out to be one of the first personal computers, now in the Computer History Museum. And it was Intel 8008 based, and I was doing computer music with it and all sorts of other fun things in an apartment in Kentucky. And it was a bit of a vacuum, but it was right at the cusp when the personal computer era was just getting started. And then it became invalidated by these newfangled things like IMSAs and Altairs, and anybody could be a computer hobbyist then. So, and then I got involved in business and writing books and doing custom industrial controls and all this other stuff. But what started happening is I noticed that I moved to Ohio and had a house in suburbia, and I realized that I was now living the American dream, which is doing things that you really no longer love to pay for things that you really didn't want after all. So I decided to hit the reset button, and I found it back here someplace. And so the trick was just to take all of my passions and blend them into a lifestyle. So my passions were things like travel and adventure, and computers and electronics, and ham radio, and romance and writing, and bicycles and all that stuff. So this was in 1983. I took a Radio Shack Model 100, which was really awesome back then, and stuck it on a recumbent bicycle with a little 5-watt solar panel. and took off around the country thinking it would be maybe a 1-year break between my previous life and my next life as a mythical consultant or something, except that never really happened. It became my career. Oddly, my old high school guidance counselor never even suggested it. But so that bike was very simple. It led to a book called Computing Across America. And it was, in a way, looking back at it from the perspective of all these years, it was really the most elegant of all of those things, because it took about 6 months to build, and I got about 10,000 miles of adventure out of it over about a year and a half, and it just worked perfectly. But one day in West Texas, I was riding along, and one of the things that happens is you're all energized and your body's pumping, and all the stories are writing themselves in your head. And I'm a writer, that's sort of what I do. But of course, I was pedaling my bicycle, so I couldn't record them. And I've never been good at doing the thing with the tape recorder and so on. And I played flute, and I started fantasizing about typing in binary, just like playing the flute. And if I had a keyboard and the handlebars, I'd be able to write while writing. So that seemed sensible. So after another few miles of this adventure and lots of articles, I did the Winnebago 2. This was in '86. And this thing had a keyboard and the handlebars. I typed in ASCII, with the low 5 bits being these strongest fingers, and the zone bits sort of remapped to the 3 little ones there. And I kept the Radio Shack Model 100, but built it into the top of the console as a little editing environment. Stuck on a little packet TNC so I could beacon as I went through small towns. I was starting to get a lot of publicity, so I noticed that if I ran the little beacon text saying that I was a high-tech nomad coming through and I was looking for a place to crash, it often worked. So it became this, this was the beginning of my high-tech couch circuit management system that kept me going for many, many years. Over the course of all these bikes, I ended up doing about 17,000 miles from 83 to 91 roughly, so this is about the middle of that range. You can see me there with my little QRP rig. I was using an Argonaut 515, which I loved, and a couple 10-watt solar panels. Basically it was home for a while, and I did both coasts of the US on that. And that had a 16HC11 in the console that took care of all the gritty stuff, including taking the Model 100's keyboard for my little handlebar keys, and so on. And near the end of that era, cellular phones were just starting to happen. And so they were about $2,000 at the time. So the one that's shown there was a OG 491. I think it was 90 cents a minute or something, I forget. But I took that thing and hacked the interface between the TRU and the base, or TRU and the handset, and managed to get a loop start phone line emulator out of it. So I ended up having a credit card verifier so I could sell subscriptions to my magazine. And sometimes I would make sales because people wouldn't actually believe I could do that. And so, well, just give me your credit card. Things were so simple back then. Anyway, that was, I don't know if you've been around tandem bicycles, which I haven't, but apparently they're famous as relationship destroyers. One day I was pedaling through Silicon Valley on this thing, and a couple passed me on their regular bikes, and a woman looked down and said, well, look, honey, he has a cellular phone on his bicycle. We should get one of those for our tandem so we can call our divorce attorney. So years passed. I was visiting SolarX, which was one of my sponsors. They donated the solar panels, so that was like going back to the mothership. But the problem with that bike, though, of course, is you noticed all those switches on the front panel. It worked just perfectly for what I intended it to do. But there was one problem with that approach, which is that it was absolutely unedited. And naturally, things kept getting cooler, and nicer computers came along, and nicer everything came along. And after a while, I started having remapped switches that still had beautiful graphics saying what they used to do, and a big documentation binder full of all kinds of clutter and notes and things like that. And I thought, all right, I just got to redo the thing. I need more of a glass cockpit, so to speak. So Behemoth was one. Behemoth is an acronym, of course. It stands for Big Electronic Human Energized Machine, only too heavy. This thing was about 3.5 years in construction. It was 580 pounds fully loaded, including all the tooling. 105 speeds, so the graining gear was 7.9 inches. So that's at a cadence of 60, that's 1.2 miles an hour. And then, of course, because I was doing that slowly and had to be able to start and stop without falling over, I needed deployable landing gear. So you can see what's the wheels down there. So I had just enough technology to compensate for the weight of all the technology. This is arms race and stuff. But the systems on here were actually kind of cool. There was a fairly robust ham station in the back. I carried an Icon 725, the Yaesu twins, the 290 and 790, which I still love. And that big white dome there is a Qualcomm Omnitrax terminal, which at the time was the cool tech for truckers, for dispatch and so on. And we did a bit of a hack on that and used, I forget the details now, but there's a little transport mechanism between it and the controller. It turned out to be fairly easy to reverse engineer, so we wrote a little pop server on the console Macintosh that convinced Eudora that it was actually Ethernet. And then that little piece of code went off to the Omnitrax terminal and broke it into these little message chunks that it liked. And you're getting satellite communications 24 hours a day at 164 bits per second. Not very good for GIFs and things, but just fabulous for email and stuff. So I had a live net connection in 1990 via satellite. And this bike had 368 HT11s scattered from bow to stern that ran audio and video, audio and serial crossbar networks. And the user interface was kind of geeky, of course. There was a heads-up display in the helmet, which is one of the private eye. And then 3 ultrasonic transducers, so that as I moved my head around, I got phase and Doppler data from the 40 kilohertz signal transmitted from the console. And then we converted that into Apple desktop bus events, which was basically quadrature of ABB. So I had a head mouse, and while pedaling down the road, I could touch a button that said, pay attention to my head position now, and the cursor would follow my nose. And click the other button. And that, of course, with a couple with the handlebar keyboard. Occasionally I was asking for something medical. It was. So it's now sitting down in the Computer History Museum, and apparently every now and then see pictures of it show up on Flickr and such. And that was a fun machine. Of course, after a while, the media got wind of this thing, and pretty soon it became a self-supporting venture. The formula that kept this whole thing going all these years was a symbiosis between the project itself and the media and sponsors. I'll get more into that a little bit later, but suddenly I joked about it becoming a career, but it really was. Between magazine gigs and speaking gigs, and pretty soon I hooked up with the Speakers Bureau, and QST did a nice 6-page article about it. It just became this sort of self-sufficient enterprise that could have gone on for a long time, except I got tired of the road. The media phenomenon was a lot of fun. Here I am at the ham shack in the campground in Wisconsin. The yellow pole there emerging from beside the dome is just one of those extended painter's poles or something. And there was a couple of those Outback whips on the end of it. So I had a folding dipole. And I could operate it while mobile in vertical mode, otherwise just sort of fall as it hit bumps. But it worked pretty well for the state of the sunspots at that time. I was chatting with a fellow in Japan one time. I was just starting to learn Japanese, and I was trying to show off my minimal abilities in the language. So I was saying things like, Oki Chikensha, big bicycle, and I'm describing all of this stuff, mostly in English. And he finally was on 10 meters in 1989 or 90 or something. And he came back and says, Harley Davidson. So here's what started happening. The media and everything just turned it into this thing, but I was getting sick of it. So I was more and more I was fantasizing about the next step and wanting to move to boats and things like that. And these interviews and speeches about the bike, which I wasn't even writing. So I ended up putting the bike in a mothership and driving around the country doing speaking tours, and obviously sooner or later something had to give because it wasn't much fun anymore. So I went to the next phase, which is take the same set of ideas and turn them into another mobile platform, except one with 2 degrees of freedom. And this is called Microship. And it wasn't just one step, of course. I won't bore you with all the intermediate stages, but basically after many years, I ended up with this amphibian pedal silver sail micro trimaran. Had deployable landing gear because the model I was addressing on this thing was the ability to take off on an unsupported venture without chase vehicles and things. And I wanted to do the coastal inland loop around the eastern United States, but starting somewhere up in the Missouri River. So lots of inland waters and lots of need to stop at night and camp and things like that. So obviously I needed wheels so that I could pull the boat out. So what started as a single item on the to-do list, add wheels to boat, turned into years of engineering with hydraulically controlled retractable landing gear that rotates 75 degrees and tuck under the solar panels and 8 degrees of suspension travel, 8 inches rather, on and on. This is, there are 3 modes of propulsion on the boat. Of course, sail, there's a 93 square foot roller furling vertically backed sail. It actually sails really well. I had some heavy hitter marine architects as consultants who helped make this happen. And there's a pedal drive, so I shall say that because there's a picture in a second. And 480 watts of solar panels. And through maximum PowerPoint tracking software, hardware and everything, I managed to get a fair amount of power out of that to drive a thruster, a little trolling motor. So there's the pedal drive unit. That's a 13-inch model airplane propeller on a system built by a friend of mine named Bob Stewart. And you pull a lever inside, and that swings down, and then it's coupled to some cranks, and the little prop moves 10 times the pedaling speed. And a funny little engineering side note here is, because we're designing all this from scratch, and we're running all these numbers and doing all this hydrodynamic stuff, and playing with prop design software, and came up with the prop design, which of course is going to have to be custom made and cost thousands of dollars. And then just for fun, we dropped in, we took a 13-inch model airplane propeller that happened to be laying on the shelf and said, well, I wonder how close that is. And it was like within 3% or something, and they cost $12.95 and carry spares. So that's just a model airplane prop. And that thing will move the boat really comfortably at about 3.5 to 4 knots, or about 4.5 on a collision course with a ferry. Miraculously, it just gets faster. There's one of the landing gear routes there. You can see the hydraulic cylinders. It's a linear motion, of course, so I had to couple it to a steering motion. And the reason for this may seem a tad excessive, but it turned out it's another one of those things that was not quite well thought through, so it's a lot of engineering, but not a perfect idea to begin with. So we got it all done as just passive castering wheels, and rolled the boat down the road, and it worked just beautifully. And then I had to do a 3-point turn, and the wheels started to do this, and then they just kind of got stuck and dragged and almost broke off the boat. So we decided it needed active steering. So there's this whole cam follower system with a handle up on the bow that implements the Ackerman steering function, so the inside wheel turns sharper than the outside wheel. It's just like way too much work. But that's the business end of it, which actually rotates the prop. And this is the peak power tracker system we did for it. This was all custom made. 8 channels of PowerPoint tracking for the solar panels. You can't just, have you been exposed to peak power tracking before, the solar panels? Anybody? Okay, yeah, the summary of this is that if you just take a solar panel and hang it on a battery, it pulls the solar panel's output voltage down to the battery's terminal voltage. And it turns out the product of that and the current that it's delivering isn't at the maximum point of the curve. You really want to be able to play around at the knee of the curve where the product of voltage and current is highest. And so what you have to do this whole little game in the software to take a little measurements on, actually run a pulse width modulation system. So we took the solar array and broke it into 8 channels, and that takes care of that. The other circuitry in that thing is something that's battery management. The other thing runs the electric thruster, because I didn't want to waste the power that wasn't being used for satisfying system loads. And often, of course, with 480 watts, there was quite a bit left over. So we just take any excess power and automatically divert it to the thruster. So that was kind of cool. And then there was the polite term is the oh crap mode. If you're on a collision course with something, you can override all of that and take all available sources of power and dump them into the thruster and go as fast as possible. But I get tired of that. And did about 250 miles around Puget Sound. Still too many projects to get done. I started getting restless, and again, I just want something simple. So I took a big break, I thought, from the Microship and just stuck a bunch of electronics on a kayak. The black box up in the bow there has an 8PRS system, and a little Cantronics, and it was a KPC3+, and the old Yaesu 290 from my bike, and I could run that to do email and all that. And I paddled around Puget Sound for a couple of years in this. And then decided that really what I wanted to do is, I can't settle down. I mean, nomad at many levels here. I still had this idea of going seriously nomadic again, but what was happening is I was getting older and slower, and sleep problems and all this other stuff. And the Microship, which sounded really cool when I was in my 30s, started sounding like more and more work. And it's a lot of stuff to schlep around. It's 750 pounds. The term micro is highly relative. So I decided to decouple all the electronics from the substrate completely. So this thing in 2005 was called Shacticus. And I had a brief flurry of publicity about this. I showed that it's CPAC in that year and got a lot of interest. And that has a little Yaesu FT817 in it and a Linux server. and the TNC and a 95 watt-hour lithium-ion battery, charge management, remote control, data collection, antenna management, and well, there's the list. And the idea of this was to have this little backpack scale system that I could use as my sort of communications laptop, and then go out and hitchhike on other people's boats or just do whatever I wanted to do to just go traveling and not worry about building a huge system. So it was all going really well, and as you can see there, I got slash-dotted, which I just thought was hilarious because my server log was at 2,865,000 hits in one day or something on my, or was that 5? Anyway, it's a lot. And that happened just as I was in the process of driving across the United States to shut down the old family homestead because my father passed away. So, you know, it's like exactly the wrong time to get slash-dotted with something that you're trying to turn into a product. So I came back and, you know, I spent 6 months in Kentucky doing all that, and came back and started eBay and Kentucky stuff, and more time passed, and Shackett was kind of slid into the background, as these things tend to do. But here's the good news, is I decided to start taking all that stuff and integrating it into a new project. So I had a brief flirtation with a Microship on steroids, which is a 36-foot folding trimaran that was a rocket ship and far too dangerous for a casual cruising sailor like me. But I did single-handed up to Desolation Sound and had a lot of fun with it for a summer. Then sold it and bought my current ship. That's the preface. This is now sitting over in Oak Harbor, and I live in Camino Island, which is a problem. But basically, this is the new. Yes.
You said on your site something about having an interest in a ship that was built with steel full chip.
This is.
This is it?
Yeah.
Okay.
Yeah, this is an Amazon 44.
There was some issue with respect to old steel?
Old steel?
Yeah.
Well, the rust never sleeps.
I see.
Yes, and water corrodes and saltwater corrodes absolutely. And in fact, it's interesting. I'm glad that we're in the Northwest because I'm having this slow ramp-up period with this because that process happens a lot faster when it's hot. You know, rigs fail quicker in the South Pacific than they do up here. But yeah, I've got a whole list of little spots that need to be taken care of. But the nice thing about steel is you can bump into things and you have a fair probability of not sinking. I actually, while I had something happen, I was tied up, ironically, at Cap Sandy Marina, and the idea was to be there for a quote on the installation of the bow thruster. So while spending the night there on a really windy night, there was this real uneven dock, and a fender slipped out of the way or something. So all night long, my hull was just grinding against the wood, ugly creosote-covered dock there. So I woke up in the morning and discovered this big bare patch on the side of the hull. And that sucks, but it would have been a lot worse if it had been a fiberglass boat. You know, it would have been clawing through fiber, you know, by that time. So it was nice to have a steel boat. Anyway, this of course is becoming the substrate for all the new projects now. And I did about 620 miles last summer getting to know the ship, and now I'm working on this as a full-time job. Here's the view from the bow heading out of Deception Pass, and, just emerging from some fog I didn't expect. So I got a real fast lesson in using the radar. It's the pilot house. It's quite pretty. And there's a nice little sort of the original steering station there. There's an inside helm and an outside helm. And then I'm building the console where all the geeky stuff goes. I'll show you. So here's what's the current project is this thing. I'm distributing around the boat a whole bunch of embedded systems using about 15 Arduinos. You know, little open source boards. Anybody use those or know them? Great. Yeah, they're extremely cool. In the past, I've used fork boards from New Micros, at Megas, you know, all kinds of little embedded micros. And I've never found any that's as easy to play with as these little Arduinos. They're about $30 each. They come in a number of different flavors, and because it's open source, all sorts of people now are making variants on it, you know, free Arduinos, and everything seems to end in Arduino. But the nice thing is it's so optimized for hacking. There's a little system you plug shields, they're called shields into the top, these little daughter boards basically, that have all kinds of other gadgets on them, like Ethernet interfaces, XD, if you need wireless, just open prototyping pads if you're just fiddling around with drivers and things like that. LED drivers, you know, and, displays, you know, you name it. And it's all really cheap, and everything's open source, and it's a really nice, helpful community. So, coupled with a little Linux environment that's going at the front end of this thing, it ends up being a really nice set of tools to be using to add gadgets to the boat. So, my first question is this readable? Oh, good. Oh, all right. That was. I've never exported anything to PowerPoint before and then not had a chance to look at it first. This is what I'm doing with the ship now. And I guess the best way to do this is just kind of wave at it a little bit. I'll go back and forth. Sorry. So this whole area over here in the lower left-hand corner is pretty much off-the-shelf stuff. It's NMEA 2000, which is the new, it's kind of the replacement for old NMEA 183, the old standard where most GPSs squirt out. That stuff doesn't lend itself very well to networking. It's just sort of glorified serial. So the industry finally came out belatedly with something that basically looks like CAN bus. And it distributes around the boat, and then all these different things plug into it. They all have these signal groups and things, and they interact really nicely and transparently. So all of these are off-the-shelf sensors, like free tank level sensors, things like that. And then up at the upper left-hand corner, there's the network side of things. I use a EVDO router that has been working extremely well. The $60 flat rate through Sprint, and had continuous coverage even well up into Canada this last summer. The router provides a local Wi-Fi hotspot on the boat, so that lets use of the laptops, things like that, be pretty painless. And I almost never need to use Wi-Fi to get to a marina access point or anything like that. And then the magic box up there is the Linux server, and I'm still not sure exactly which Linux server that would be. I'm kind of leaning toward the little Alucia, which is being made for third world applications, and ALEUTIA. And it's runs on 12 volts, and it's a little Atom-based, and it's just a little Ubuntu box that costs a couple $100 and seems to work really well. The reason that's kind of a critical thing is that that's going to be on all the time, and of course that means power I care a lot about because I'm in a solar battery environment. And I thought about using the Mac Mini there, but even the new Mac Mini is about 13 watts when it's idling, so small-scale Linux is good. And then there's a big pile of USB, and actually I want to learn more about the previous speaker commenting that all USB hubs are not made equal. I'm just about to find out which ones I need, things that can be left on continuously and not draw power too much, not generate too much RFI, and basically play nice with radios. As you know, computers and radios have sort of a long, rocky history, and they sort of dislike each other in many settings. All this stuff has to work well together. And the big map, or the big grid there in the lower right is all these Arduino boards. You can see each one of those things has some dedicated function. And what's neat about them is they're so cheap, and they run off of the USB cable that's run of them, that provides all the power, or they can be powered locally. So you can see some of the applications of these things. One I just am working on right now is the sewage one here. And it sounds like such a trivial thing, but there's some really awful things you can do with a holding tank on a boat. Like forget to open the stop cock that takes the output of it and dumps it overboard if you're offshore. Forgetting to open that and turning on the macerator pump. And that requires, that's just a mess that you don't ever want to contemplate. It just basically explodes. And so, there's all these things that people have to remember to do. Boats are complicated. It's like your whole house system except a lot more because it's propulsion and navigation and all this other stuff. And there's so many ways to screw up. And sometimes you're tired, and sometimes you haven't been on the boat for a while, and you sort of don't remember the sequence of operations. And so what I'm trying to do is, without interfering, kind of a key point here, I don't want to interfere with the fundamental simplicity of a sailboat. I'm not going to use microprocessors to run control lines and turn on the nav lights and things like that. But I'm adding a layer of awareness on top of the entire system. So for example, every single valve and stopcock on the ship has a magnetic reed switch on it and a little neodymium magnet gorilla glued on. So the system knows the status of every valve. So in the case of that sewage node, if I turn on the breaker that allows me to go over and pull the protected little switch to turn on the macerator pump, and it notices that I haven't opened the vent and I haven't opened the thing overboard, I get actually it's a bulldozer backup beeper, which is right there by the switch. And if I fail to notice that, well, then I deserve whatever happens. And there's another system called the Waterworks, lower right-hand corner. And again, lots of valves, but it's also got a ultrasonic double filtration system as well as a reverse osmosis water maker. And I can move water from tank to tank on the boat and run it through the filters, and there's all these different things this thing can do. And it suddenly occurred to me that instead of depending on sort of strange tank level sensors that came with the boat, which I can't get at, and it's hard to get down there to add new ones, all I have to do is just meter the flow. So there's a single central flow meter at the one choke point where all the water goes, whether it's from shore or into the house system or tank to tank or through filters or whatever. And so the thing will always keep track of the modes of all the valves, the amount of flow that's happened at the time, and whether or not I've pushed a button saying I've just changed a filter or something like that. So those kinds of really simple applications. But all of those things are reporting up to the Linux hub, which has then keeps a map, a database, a real-time database of all of the data points on the boat, which is of course archived and timestamped. So now you can do things like look at your solar array over time and notice if the performance of one panel is starting to drop off relative to the others, those kinds of things. So let's get to the communications, which is what this is all about here. So this is another node as far as the hub is concerned. This is node V, or voice, and it's actually one of the more fun ones. There's three things going on here. One is the assumption that occasionally something might happen to the server and I might want to get in through a back door and somehow do something with it. So one of those little Arduino boards, it's a little $30 mega boards, will have an Ethernet shield on top of it, and it's just sitting on the ship network. So I can log into it from a web browser at my house, or from Cyber Cafe or wherever, and reach in and then kind of boot the Linux server and interact with it and so on. So that's kind of a sort of a backdoor to kick it back in. But over at the right, those trusty old Yaesu twins, the 290 and the 790, are always on, just like the server. And the thing I like about those, we've got all these whizzy new radios, which I love as much as the next guy. But the thing that's cool about these is they have about a 50 milliamp receive standby. And you look at any automotive radio now, at least the ones I've measured are all around an amp, just sitting there doing nothing. And yet they transmit at 25 watts, so I don't know where else to get that ratio in any modern piece of VHF, EHF gear. So the VHF one is there to be a little packet backdoor, so I can do that from my backpack. And the UHF one takes care of the HT. If I'm off in the dinghy someplace and I want to query the boat and say, what's the status? Do I need diesel or whatever? I can send a touch-tone command from the HT. The DTMF decoder is, of course, seen by the Arduino, which then uses a little V-stamp speech synthesizer board, yanks the push-to-talk on the 790, and then gives me a voice response. So there's all these levels of commands and queries that I could do to get either stuff at the server level, how's the system doing, or whatever. Anything that's on the ship, obviously, I can get to. So this is the current project. And that leads to, first of all, before we talk about the next step that I want to talk about is a little more philosophical. So before mode changing here, any questions about boat pipe or anything else? Yes?
What do you do for backups for all this critical data on your boat?
There's a second server, another one of the Mac Minis is buried down in the hull in an undisclosed location. And it acts as a file server. And then I do offsite backups of really critical stuff. And I've got that running as just one of those background backup apps. It is above the bilge level, yeah. Yeah, the computers, I talk about computers and radios not being friendly together. Computers and saltwater are even worse. The times I've seen electronics that have been kissed by saltwater, it's just a sad sight. Yeah.
These Arduino boards, how is it that you can connect those? You've got a number of them. Are they all on the network, or how do you, or are they connect? If you've got, say, 20 of them, you need 20 USB ports. What are you doing?
Yeah, it's just USB is a tiered star, right? So you can just stack hubs underneath each other to get as many ports as you need. And then they all just have these virtual serial ports. The beauty of it is just, you just make all the serial ports you want out of the same cable, using the hubs. So, yeah.
Okay.
Do you have mechanics of running USB lines?
Oh, okay. Related question. Steve just asked how I deal with the mechanics of running USB lines long distances. I probably should mention they're not all USB directly to the Arduino. So that's only good for, 6 meters or something, or some magic number. Anyway, shorter than the boat. So in places where I have to go further, I use the little keyspan USB to serial converters, and then I can run serial as far as I want. And as near as I've been able to tell, it works equally well. So, and then in cases where it's just really hard to get wire, I use XBeach. So there's one of them is on the dinghy, and it's doing things like dinghy security and all that other kind of stuff. And I do plug in the dinghy now and then to be charged, but I don't want to have a network cable going through it all the time. So it's got, I don't know yet what the range is, I haven't tested it, but that counts why I was. Yes. Yeah.
So the Callahan that hull, is that like custom made?
The Microship trimaran?
Yeah.
Want to go? Yes. Well, actually, yes and no. I decided there was no point in reinventing the hull. I would never do it as well as other people have. So I got a Kevlar canoe in the form of it was a Winona Odyssey, 19-foot canoe, and it was a perfect hull. And then I took the outer hulls that were designed by Jim Brown for the Fulmar and had a set of molds, or had that pulled off the original molds of that. So that all the hulls were designed by marine architects. And then
The molds already existed and you had somebody else make the mold.
yeah, the design already existed. I had the hulls custom made, but it was to an existing design. And then everything from the original gunnel of the canoe and up about 2 inches was all homemade, and that's all that custom Divinicel core fiberglass stuff. And I also had a couple of real marine architects in the loop, because things like center, you can really screw up a boat and just never get it to work right if you don't get certain numbers correct, like position of the mast and position of the board and things. So I had 2 different marine architects get involved. It was a good move. It's not what I would have guessed. So, there was somebody over there? No? Okay. Any more on boats? Yeah.
Just a question. There's kind of 2 schools of thought or extremes in people like sailboats and businesses. You got the William Larry Harvey approach where there's no engine and it's a very simple boat, where they get have more fun enjoying the fun of the boat because the system is simple. There's the British American system where you have the 50-60-foot boat is floated like 100 years where 75% of the boat is because they can't possibly keep up with those position. How are you addressing the needs of keeping these things weather resistant so that you're not talking about what is the technology
Right.
that comes out of the
I'm already running into that stuff that came with it, much less the stuff I'm adding. It came with an autopilot that was broken and a head system that one of those electrical things didn't work with the head. People. Anyway, well, first of all, the layer of stuff is not mission critical. Okay, so there's a few answers to that. One of them is that the things that are necessary for navigation and operation are as off-the-shelf and robust and easily replaceable as possible. So, like off-the-shelf, the chart plotter at the outside home, that's going to get the most abuse. It's just I'm not sure which one it doesn't matter. Just plugging it into game members. If it fails, I get another one. That sort of thing. The complex systems, all of this stuff can be sacrificed. The boat will still work without it. But because I'm a geek and like this kind of stuff, it increases my enjoyment of the process. If it turns into an ongoing maintenance nightmare, I'm going to say a different thing someday. But what I'm trying to do is keep all the hardware as off the shelf and simple as possible so that everything's behind the code. And of course, spare Arduinos and spare Linux boards and things like that are really nice. And the exception is places like there's one of the nodes that was on there, too far back. Yeah. This thing right here is kind of key, and I'm just going to get circuit boards made for that because it's so critical that I might have to replace it. It's a crossbar network. I used to do serial crossbar, but that's not all handled like this. But all the audio and video and even a few other configuration kind of signals run through a bunch of DPDT latching relays driven by long SPIs, shift register chains. And so much depends on that. Including a lot of things I didn't even mention, like a double piano and music composition studio that goes on there, so there's a bunch of that kind of stuff that's getting switched on. Anything like that that's really, really complicated would be way too much to hand wire or connect to a whole perf board or something. So there's the answer, I guess, accepting the possibility that things are going to fail and just trying to make it as easy to deal with that as I can. Oh, yes, well, I do. Yeah, absolutely. Sorry, I should have mentioned that. Yeah, I'm using conformal coatings, things that are really exposed to sometimes in mineral oil. Undersea pluggable connectors. I use Seacon connectors with a little gold rim and 2 rubber tip and a rubber sleeve. Those kinds of things. The most sensitive area is probably the console, but it's also moderately well protected inside the boat, although if I take green water over the stern, all bets are off, everything's going to get wet. So, yeah, everything's conformally coated and sealed wherever possible. Yeah.
What do you plan to do in terms of, it looks like it's very possibly a middle-winged, sailable blue water boat that could go all the way around the world. So what do you plan to do?
Well, it can. Let's see back to the boat picture. There's a lag time. There we go. It actually has done both coasts of the U.S. and through the Panama Canal both ways before I got it. There are 6 of these made, and it's 2 of them have circumnavigated, and one's in Africa at the moment, partway on. So this coming year, if I don't get too distracted by other projects, I'll probably do another 1,000 or so miles up inside Vancouver Island. Princess Louisa Inlet is one of the holy grails, of course, and I want to get up into the rocks in that area. If things are going really well and we have the time, we'll probably try to circumnavigate Vancouver Island and come down the outside for a first taste of that. And then the bigger picture is starting some of the world cruising routes and heading down the Pacific coast and turning right into San Diego, San Francisco, South Pacific, and whether I should mention something. I don't have a specific objective as far as distance. Way back in the bike era, I learned that if you think too much about where you're going, you lose respect for where you are. And that kind of applies to life as well as bicycle trips. And I found that it's really easy to set up a goal like, I am going to circumnavigate. Well, then if you don't, now you've failed. So I don't want to do that to myself. I've made that mistake before where a project becomes defined by some endpoint as a great objective. And you can't measure a success in those kind of terms. So in general, I'm going to aim myself off in that direction and see what happens. Every time I've ever predicted where I was going to go, it ended up being wrong anyway. So I have an old, I used to write a column in USA Today when I was on the bike, and it was kicked off with a cover story in the money section. And it's just hilarious to look at it now because it's, his route so far and where he's going. And it showed this big figure 8 around the United States. And, the actual trip was just as long, but it wasn't even remotely like that. So I just learned to say, I'm already there, right. And that's the nice thing about living in a sailboat is you really kind of are already there. I mean, even just bobbing an anchor, the epic crossing between Camino and Windy, it's just so nice. I try to remind myself occasionally that people come from all around the world to go sailing here. So, yeah.
Are you taking any special precautions against that eventual EMP discharge that you're going to get from the air?
Well, I was going to do everything with relay backups and stuff, but I would say this is probably not easy. Backups, spares back at the home base facility are probably the only way around that. What's more likely than EMP is lightning. And, I've had friends lose all their electronics to a lightning strike, and thought of that as kind of horrific.
So you're not doing any special optical isolation or anything like that?
I don't think optos really help all that much when it comes to lightning. Optos will help with generator noise and glitches from battery arcing and that kind of stuff, but I don't think it would do much for a lightning strike. I mean, even people's spare radios in a drawer end up being toasted sometimes just for the fuel density. So you just have to accept the possibility of it and have spares and have a strategy for putting it all back together again someday. I mean, the good news is that it is a steel boat. It's a big aluminum mast. I'll probably put those little, fingery things up there that dissipate the charge supposedly. I haven't heard of any real bad lightning strike problems with steel boats, but I could be the first. So. It's just a possibility I have to live with. Yeah.
Yeah. With all these systems you have installed on your boat, requiring some attention, doesn't that interfere with the situational awareness?
That's a good question. Did y'all hear? He asked if there's all the systems on the boat, does the attention required interfere with my situational awareness? And somebody earlier mentioned Star Trek, and that sounds silly to say, but the idea here is not to have distractions, but to have things that increase my situational awareness. So in other words, just being able to look at what is basically a boat's web server. I'm looking at a website, that is the boat, and be able to see at a glance the status of all my tanks and valves and whether the bilge pump is cycled and those kinds of things should actually be better seamanship. Assuming I don't depend on it.
I also have a boat. I put lots of stuff on it. I love gadgets and technology. But sometimes you see a reading and you have to stop and think about why is it 12.2 volts? It should be, and you start thinking about the system and what could be going wrong, and you find yourself very distracted.
Yeah, I think that's more of a mental exercise than an admonition to not use technology.
No, I would.
Yeah, it's a good thing to remember though. Even a chart plot can be dangerous that way. There's quite a few stories, and I'm embarrassed to admit I've kind of done it myself, where you know, it's like the boat gets to be like a video game after a while. You're looking at this really pretty picture and this really nice sunlight readable active matrix screen, and you've got your wheel, and everything just feels great. And you know, you may not know that the chart datum is a little off, or the buoy has moved from when it was last, when the charts were made, any number of things, or the thing that you're going to run over because you're not watching. Yeah, the not watching, my most embarrassing not watching event was up in Desolation Sound, and actually, well, let me say real quick. I was sailing along, chuckling at the antics of a powerboater who was calling for help on Channel 16. They hit a rock because they were down below having lunch and not paying attention. And they were okay. I mean, they weren't sinking or anything, but they were scared. And the Coast Guard came out, diver down, fixing their boat and all that stuff. And I rounded Sarah Point going into Desolation Sound, and I saw them over there. And I'm like, okay, I'm going to stay well away from those guys. Everything's cool, you know. And I'm just cruising along, just enjoying the day. And all of a sudden, the coasties are all looking at me and gesticulating. And I waved back, you know, they're looking at the pretty trimaran, you know. And no, they're gesticulating more vigorously. And they disengaged from the boat and kicked up this huge rooster tail heading straight for me. And my first thought was, oh no, I didn't put the Y valve back in the right position. I'm going to get boarded. You know, I'm all paranoid. And then I could hear, reverse your boat, you're going to hit a rock. Well, it was the same rock that the powerboat hit. They had been drifting down current and downwind while fixing the problem. So I think, oh, the problem's over there, everything's cool. So I just let my guard down. And I was headed right for Stacy Rock. And I went back later and looked and took my track. I have a data logger, and I make a KML file, and I look at it on Google Earth, and you can actually see the little light spot in the water about one boat length ahead of me as I reversed. Anyway. Yeah, they were really sweet about it. I wanted to send them a box of chocolate. They said, oh, no, that's all right. That's what we do. We get this other thing here. Okay, so the final point, I know I'm running short on time here, but all of this has led to a kind of a set of ideas that are kind of worth sharing, I think, because there's a lot of people in this room who are building really interesting stuff, and a tremendous amount of creativity here. And as you know, sometimes that has to compete with day jobs and economic realities and things like that. And one thing I have been doing since 1983 now, that's about 25 years, is figuring out how to make a living playing. So I've just put up this PDF. It's on my website. I've got a little online store. But basically what it's about is the tricks, it's sort of my tricks of the trade, you know, about how to marshal a bunch of different resources in order to sort of keep yourself moving, keep the project moving on limited resources. You know, I've never been independently wealthy or anything like that. I mean, I had someone, I sold the house in Kentucky, and that gave me a chunk of money to buy the boat, so there's that big chunk. But all the stuff before that was really very much hand-to-mouth freelance writing, and I'm just barely eking out a living. So what's interesting here is that there's a number of ways to kind of get other people's energy going and other people's money going. Like one, I don't have time to go through this entire thing, but one example is sponsorship. I used to get, I've had something like 160 corporate sponsors on the Microship project, and about 140 or so on the boat. And of course, I would often get email from people saying, hey, how do I get companies to give me stuff? And it's not that easy, but it almost is. The key thing in sponsorship is not to ask for cash. Of course, you know, as you know, when you're asking people for money, you start encountering things like return on investment, and you know, people who think in those kinds of numeric terms and want performance bonds and all that sort of stuff. So over the years, I've put together a lot of ways of returning value to the company beyond just flying a logo or something like that. In fact, flying a logo really doesn't work anymore. You know, some people they'll get a title sponsor for something like an Alpine Ascent or something like that, with one big company name on it, sponsored by REI or whatever. And that kind of makes sense. But for me, can you imagine 160 little logos all over my sail? You know, it would be ridiculous. So there has to be something other than that. And so you know, of course, one of the obvious things is because I am a bit of a geek and I occasionally hack stuff and do strange things with it, I return all of that stuff to the company. So, you know, I unpackaged your thing and I found this little interface here, and I wrote this piece of sweet code to make this graphic. Here you go. And that sort of stuff goes over really big. As does doing things like participating in their marketing programs, appearing in trade show booths, doing talks for the Apple company, you know, where the employees are. Some companies are giving me stuff just because they sort of want their own troops to be excited about interesting ways that their technology is put to use. Like years ago, Larson Electronics gave me some of their antennas, which I love. Half-wave, 2 meters, best antenna ever for the light. Didn't need a ground plane, worked great. And all I had to do in return was just show up at Larson one day and spend about an hour or so doing a show and tell and talking for the crew and all that stuff. So I found it's making some effort to get corporate involvement tends to pay off pretty well. Another thing, of course, is getting a team involved. And similarly, every good deal is a win-win, so you have to return a lot of value in those ways too. And it's it's been a little hard since I've been at Camino Island because it's an isolated area relatively. But when I had the lab down in Silicon Valley, and before that in San Diego, we had such a social setting. When I was working on the bike, for example, at Sun Microsystems, a typical evening was maybe 5 or 6 people in the lab, volunteers. One guy was a newlywed. He came over almost every night for about 4 or 5 months, working on the system for me. Because there was just this huge geek energy of all these people being reminded of why they became engineers and doing something for fun. And some of the some of the stuff that's happening in this room is certainly qualifies because a lot of people find this stuff pretty cool and want to help. So you can leverage that. By the way, back there in the bike lab one night, it was one of those busy nights. There was somebody wiring, there was somebody else writing fourth code for the crossbars. A friend of mine was at the milling machine making parts for the landing gear. I think there was like 5 or 6 of us working, and I heard the mill spin down. And my friend Dave said, "Hey, Roberts, does it ever make you feel funny that so many people are working so hard to get you out of town?" So anyway, if that's the kind of thing if that's interesting to you, if you're working on a project that's just sort of not reaching escape velocity because it's just too big for one person to do, it really is, talk to me about it or send me an email or something and I'll give you some tips and pointers because there are really a lot of ways to, it's almost like a martial art, you can take other energy and kind of redirect it just slightly so that it helps you out. And that's been how I've gotten away with this over the years. So any more questions? I knew this looks great. How's my time? Whatever.
Perfect.
Okay. Then questions? The new book? It's an Amazon 44. Yeah, it was Graham Shannon was at the time. Actually. What? Yes. Great. Thank you.
So, you talk a lot over the history of the technology for its physical security systems. The alarm horn on the bike is it's considered a but are you not your internet connected? No. Internet security?
So glad you asked. Yes, the question is about internet security in the boat. Forgot to mention that in the upper left-hand corner of the big block diagram, you saw 4 cameras sort of in a staggered pattern. I'm using these little Axis webcams, the Axis 210. And initially I just stuck the thing out there and I could look at it with a web browser, which is cool, but of course I may not happen to be looking at it at the time somebody happens to be breaking in. So then I started reading the manual and noticed that it's got this motion sensing tool, so you can draw a little region in the video screen and set thresholds and all that, so if something moves big enough, moves fast enough, etc., it triggers the thing to respond. And the response is to send me email, to send a text message to my cell phone, to email the port and start FTPing video frame grabs to my server, which is my Microship.com site. And so all of a sudden now I've got this autonomous little camera there which just works. I didn't have to build any of it, I just sort of configure this stuff. And if somebody breaks into the boat, it's entirely logged off-site, and I hear about it through 3 different pipes. So there will be 4 cameras on the boat with varying degrees of that sort of thing. And then of course all the, what's that? Oh.
The seagull lands on the...
This is inside. No, the laser hits the seagull. That's one more security anecdote. The bike had a somewhat amusing security system. There were 6 different sensors, but the most fun part was that if it was moved physically, it would start to talk. It had a speech synthesizer, and the most common thing was "do not touch," or "you will be vaporized by a laser beam." And of course, that's just silly. But I was down in South Alabama one time, and I was in a restaurant, And I came out just as some guys were standing around and hunting garb on and stuff, and one of them kind of nudged him with his foot. And it said that, and they all took about 3 steps back. Whoa, dude! And we all had a good laugh, and I showed them the bike and everything, and it was all fine. And months later, I was in Silicon Valley, and I was speaking at Apple, and I had the bike in the Mariana campus, Mariana building in the cafeteria. And some guys were all standing around it, and I was over talking with my host there. And one of the guys was touching something, and it said that, and nobody backed off. They said, "Hey, that's the Berkeley speech technologies algorithm." Anyway, I'll leave it at that. So. Thank you.